Algebra 5-6, Note 6, Standard Deviation. Understanding standard deviation. A consumer's organization is planning a study of the various brands of batteries that are available. As part of its planning, it measures the lifetime, how long a battery can be used before it needs to be replaced, for each of 6 batteries in brand A and 8 batteries of brand B. Dot plots showing the battery lives for each brand are shown below. Find a typical battery life for each brand. Choose a measure of center that is most appropriate for the shapes of the distributions. How do the two brands compare? So if we look at brand A, which is the top line, it looks like a pretty symmetric distribution. And when they're symmetric, we would use the mean. So let's first jot down that it's symmetric and then we are going to use the mean. To find the mean, we need to add all the values together and divide by the total amount of values we have. So let's mark these values here. This first value looks like it's about 83. We have 94, 96, 106, and it looks like 113 and 114. There are 6 values, so let's go ahead and add them up and divide by 6, and we get a mean of 101. Brand B. Again, let's label these. This looks like it's 73, 76, 92, 94. This one's 110. And then 117 and 118. We have one out here. Since I don't see a 125 mark, this is probably about 124. So we have 8 values on there. This data also seems pretty symmetric. So again, we would use the mean. And the mean, when we add them all up and divide by 8 this time because there are 8 of them, we get a mean of 100.5. How do the brands compare? I would say that they're pretty close. It does look like brand B is more spread out than brand A, which means it's more varied, but overall their average battery life is the same. So let's write that down. Okay, letter B. Do the battery lives tend to differ more from battery to battery for brand A or brand B? Explain in terms of variability. Well, I just said that brand B has a greater variability, so we just need to jot that down. And again, variability means that it's more spread out. Letter C. Based on parts A and B, which battery brand would you prefer to purchase and why? Well, they both have the same mean. However, brand B was spread out more. It had more variability, which means brand A was more consistent in its battery life. So if I'm choosing a battery, I want to know how long the battery life is. I want something that's more consistent. So in this case, I would choose brand A. brand A because it has a more consistent battery life. Which means it's less varied. And it also has a slightly higher mean. There are other ways to measure a data set's variability besides range and interquartile range. One way is to measure the deviations from the mean. To find deviations from the mean, you subtract the mean, which is this symbol right here, an X with a line over it, from each data value. So this is each data value minus the mean. Calculate the deviations from the mean for each brand. Remember, brand A had a mean of 101. So again, that's the symbol for mean. Mean equals 101. And brand B had a mean of 100.5. So what we're going to do is take each data value, which are listed up here, those are our x's, and subtract the mean. And yes, you will get some negative numbers. Let me zoom in here. We have our data value is 83 minus the mean of 101, and we get negative 18. We have 94 minus our mean, 101, which is negative 7. 96 minus 101, which is negative 5. 106 minus 101, which is 5. 113 minus 101 is 12. And 114 minus 101 is 13. So those are the deviations from our mean for brand A. Let's do the same for brand B. This time our mean is 100.5. So 73 minus 100.5 is negative 27.5. 76 minus 100.5 is negative 24.5. 92 minus 100.5 is negative 8.5. 94 minus 100.5 is negative 6.5. 110 minus 100.5 is 9.5. 117 minus 100.5 is 16.5. 118 minus 100.5 is 17.5. And 124 minus 100.5 is 23.5. So there we have the deviations from the mean. Notice that for brand A, 96 and 106 have positive variations. Or have opposite deviations, excuse me. What do the signs mean? Do they have the same or different variability? Well, 96 is 5 less than the mean, which is 101, and 106 is 5 greater than the mean, which is 101 again. So even though they're opposites, they have the same distance away from the mean. So we would say that they have the same variability. Take a moment to pause and jot that down. Letter E. Ignoring the sign of the deviation, which brand tends to have larger deviations from the mean? So if you look back at your chart on the previous page, you're looking for, again, ignoring the sign, think about the absolute value. The brand that has larger absolute values for deviations would be brand B. Complete the statement. The greater the variability or spread of the distribution, the greater the deviations from the mean. Calculating standard deviation. Instead of having to look at all the deviations from the mean, it'd be easier if we just had one number to represent a typical deviation. This is known as the standard deviation, which is the square root of the variance. To calculate, we will square the difference of x minus the mean, since the sign of the deviation doesn't matter. Next, we'll find out an average of those squares of those numbers. And then because we squared everything, we then have to reverse it by taking the square root. It sounds complicated, but let's just take it step by step. Please note that standard deviation should only be used to measure variance in a distribution that is approximately symmetric because it deals with the mean. If we have a skewed distribution, either right or left, we would use the median as a measure of center and the IQR as a measure of variance. So a couple things we have to look at here. Standard deviation formulas. We have two different ones, one for a population and one for a sample. Remember, a sample is a list of all possible outcomes, whereas a population is a large group of data usually represented by a sample. So population is the whole group, and a sample is a piece of that group. So take a minute, I'm going to type out what each of these symbols mean underneath, so take a minute and pause the video and jot them down. So here are the data, or the symbols. Make sure you jot down what those mean. Find the standard deviations to the nearest hundredth for battery brands A and B using the tables below. Which formula should be used, the population or sample standard deviation? Now this again is dealing with the batteries brands A and B, and we know that those are only samples of the entire population of batteries. So these are both going to be samples. So we are going to find the sample standard deviation. And let's take this formula step by step. So what's done for us here? We've got the values and the mean already written in for us, and then the variances, which we found on the previous page or two. So now what I want to do is take these numbers, the deviation from the mean, and I want to square it. So in your calculator, negative 18 squared, which is 324. Negative 7 squared, which is 49. Remember to put that in parentheses. Parentheses, negative 7, close parentheses, and then square it. Negative 5 squared is 25. 5 squared is 25. 12 squared is 144. And 13 squared is 169. So now what I'm going to do with all these values is I'm going to add them. This symbol right here means summation. It wants us to add all of these values, so add this entire column. When we add those values, we get 736. N represents the number of data we have. So for brand A, we have 1, 2, 3, 4, 5, 6. N is 6. So this piece right here is just this up here, the summation of the square of the deviations. So our numerator is going to be 736. And the denominator is going to be n minus 1, or 6 minus 1. So this equals 736 over 5, which equals 147.2. And then what we're going to do is take that number, 147.2, and find the square root. We get 12.1326. Let's round to the nearest hundredth. 12.13 is the standard deviation. Go ahead and follow the same procedure for brand B. For letter B, I just want to make a generic statement here. Remember that when we have a larger standard deviation, the data is more spread out. When we have a smaller standard deviation, that means the data is closer to the mean. So again, the larger the standard deviation, the further it is away from the mean. Again, I want you to do letter C the same way I did A on the previous page, and also letter D. We can also find standard deviation using your graphing calculators. So when we do this, I want you to round to the nearest thousandth. And remember, we want to know if it's a population or a sample. So in this box, which I'll describe in a moment, we're going to find the standard deviation. Before I get to that, we need to set something up on your calculator. I want you to hit the second key on your calculator, which is in the upper left-hand corner. It should be blue. And then I want you to hit catalog. If you look at the 0 key, which is on the bottom left, it's a white key. Above it says catalog. So again, hit second, catalog, and you should see this screen right here. I want you to hit the down arrow until you get to diagnostic on. Once you get there, I want you to hit enter, which will bring you to this screen, and then enter again. This is something that we need to have on in order to do standard deviation in the calculator. Now that the diagnostics are on, we can go ahead and enter this information into the calculator. I'm going to do letter A for you, and then you're going to do letter B on your own. So letter A, history test scores of every student in class. You are talking about every student, therefore we are talking about a population. So when we do this in the calculator, we are going to look for this symbol, and that will be our standard deviation. And again, if you remember, this symbol right here is standard deviation of a population, which is what we have. So here's how we do it in our calculator. You're going to make sure you're at the home screen. If you're not, hit second, quit. You're going to hit the stat button, which is near your arrow pad, and it will bring you to this screen. And you're going to hit enter. We want to hit edit. You can either hit enter or you can hit 1, which will bring you to a bunch of blank lists. What I want you to do is type in your numbers that you have in letter A. So 71, 72, all the way to 85. And you should have 19 numbers. Down here, this is number 19, and what's highlighted is number 20, which there isn't one. So you'll know you typed in the correct amount when you see this here. Now, it's a good idea to go back, and you can hit the up arrow to go back, to make sure that you have all the correct values in there. Otherwise, you will not get the same answer. Okay, once you have all the data values in, you're going to hit that stat button again. But this time, you'll hit the right arrow so that it's highlighting the word calc. We are interested in option 1, which is one variable statistics. So go ahead and hit enter. When you hit enter, it'll bring you to this screen. What's blinking here doesn't show blinking on my screen. That says L. This refers to list number 1, L1. If you recall back up when we put it in, we put the values in list 1. Okay, so we wanted to calculate the one variable statistics for list 1. So go ahead and arrow down to the word calculate and hit enter. It's going to take a moment, but then it will give you all of these values. This tells us the mean, the sum of the mean, and so on. So we have here, this would be the standard deviation of a sample, and this would be the standard deviation of a population. Because we have a population, our standard deviation is 8.1325, etc. It wants us to round to the nearest hundredth. 2 is in the, thousandth. 2 is in the thousandths place. The 2 becomes a 3 due to the 5. So we have 8.133 as our standard deviation. If we go back to our page here, our standard deviation again is 8.133. Letter B, shoe sizes of a random sample of 10 adults. You're going to go through the same process as you did before, right up here. Go back and look at the screenshots of the calculator if you need to. Only this time, you are going to focus on the sample standard deviation.